Good day everyone. This video is a course requirement in our subject, which is math analysis for teachers. It is my pleasure to share with you the assigned topic that was given to me by our professor, Dr. Jess Pizarro. And this topic is titled Applications Involving Absolute Extremum on a Closed Interval. By the way, this is your teacher, Kevin V. Orpilia, MSc Mathematics student of a graduate school of St. Paul University, Philippines. So we consider some problems in which solution is an absolute extremum of a function on a closed interval. Use this is made of extreme value theorem, which assures that both an absolute maximum value and absolute minimum value of a function exist on a closed interval if the function is continuous on that closed interval. So let's start with a graph, and let's say we have a function that has a graph like this, and let's name these points A, B, C, D, E, F. So the absolute maximum is the highest point in the graph. So what do you think is the highest point in this graph? So this is the highest point in this graph so far. So this is called the absolute maximum, while the lowest point is called the absolute minimum. So the highest peak here is not the absolute maximum, but rather it is a relative maximum, and this part here is a relative minimum. So to find the absolute extrema on a closed interval, we are going to find for the absolute minimum and maximum for all x in the interval. So let's have a quick review before we go to its application. So let's determine the absolute extrema on the interval 1, 4, and the function f of x is equal to x squared minus 4x plus 9. So let's start determining the critical numbers or critical value of this given function by getting its derivative. So based from the equation, we have the derivative 2x minus 4, and let's equate this into 0. So some of you might thinking, why 2x? So because we are going to transpose this 2 into this part in order for us to get uh, the derivative, then it will become 2x, and then the derivative of negative 4x is negative 4, and then the derivative of a constant is a 0. So in order for us to determine the value of x, or the critical value, we are going to transpose 4 into this part, and we have like this. So we have 2x is equal to 4. So now, um, in order for us to leave x in this part, we are going to divide both sides by 2. So now we have x is equal to 2, and this serves as our critical value. So now, to determine the absolute extrema, we need to evaluate the given function using the critical value and the two endpoints, which are 1 and 2. So these are the endpoints 1, 2, and using the critical value 2. So what if the value of x is 2? So this will give us uh, 5, because 5 squared minus 4 times 5 plus 9 is equal to 5. So you can check this by using your calculator. So while you are verifying the value of x, let me find the value of x2 using my calculator. So we have shift x squared minus 4x plus 9, then just click calc and write or input 2 since the value of x is 2. Then we have 5. So that's very easy. So next, we have when the value of x is 4 in this equation, it will give us 9. And we can check again uh, in our calculator. When we have the value of x as 4, just click calc and input 4. And yes, we've proved that it is also 9. And then if the value of x is 1, this will give us 6. The absolute maximum is 9 because it's the highest value. How about the absolute minimum? Okay, very good. The absolute minimum is the lowest value, which is 5. So that's just very easy in finding for the absolute minimum and absolute maximum. So now let's take a look with this problem. A cardboard box manufacturer wishes to make open boxes from pieces of cardboard 12-inch square by cutting equal squares from the four corners and turning up the sides. Find the length of the side of the square to be cut out in order to obtain a box of the largest possible volume. So by the way, this is now the application of this topic. So let's take a look with these figures 4.6.1, 4.6.2. So the 4.6.1 represents a given piece of cardboard and the 4.6.2 represents the box. So we now let x be the number of inches in length of the sides and let V be the number of cubic inches in volume of the box. So as we can see in the figures that the number of inches in the dimension of the box are x, 12x minus 2x, and then also 12x minus 2x. So the volume of the box is the product of the three dimensions. So v is a function of x, and we write it like this. V of x is equal to x times 12 minus 2x times 12 minus 2x. So by multiplying this equation, we get v of x is now equal to 144x minus 48x squared plus 4x cubed. So if x is equal to 0, the value of our v is also 0 because 144 times 0 minus 48 times 0 squared plus 4 times 0 cubed, the value of v will give us also 0. So what if x is equal to 6? So the v value now is also 0. So the value of x that we wish to find is in the closed interval of 0 and 6 because v is continuous on a closed interval. So now let's proceed to our first step. And what is our first step again? Yes, very good, which is to find for the derivative of a function or to get the critical value. So now we have an interval 0 and 6. So we have now the derivative of the original function because the derivative of 144x is 144. The derivative of negative 48x squared is negative 96 because we transfer this 2 into this part, then multiply it by 48. Then we are going to subtract the exponent by 1. So 96x, negative 96x plus 12x squared. So just transfer 3 here, then multiply it by 4, then subtract 1, the exponent. So we get 12x squared. So by simplifying this, we get 12 times x squared minus 8x plus 12. So let's use our calculator to solve for the values of x, and that serves as our critical value. So kindly get also your calculator to solve the critical value or the values of x with me. So let's write uh, mode, and then click 5, and then click 3, then insert 12 equal sign, negative 96 equal sign, and 144 and equal sign. So we're just following the order of the exponent, where the highest exponent must come first before the lowest exponent. So now this will give us the values of x. So the first x is 6 and the second x is 2. And this now is our uh, critical values, which are 6 and 2. As you have noticed in the previous problem a while ago, in our first problem, that we have only one critical value. So because the equation or the function is a linear function, and the function in this problem is a quadratic function, because there's a 12x here. So I think if it is a quadratic equation, there are two critical values, and if it's a linear equation, there is only one critical value. So these critical values here are both closed in the interval 0 and 6. So we know that our critical numbers or critical values are 2 and 6, and our endpoints are 0 and 1. So going back to the original function, which is 144x minus 48x squared plus 4x cubed. So let's just substitute the values of our critical values and endpoints. So therefore, we have it like this. So if the value of x is 2, this will give us 128. But to check this, let's choose our calculator. Uh, so we use our calculator now to check whether if the value of x here is 2, then it will give us 128. So let's start. 144x minus 48x squared plus 4x cubed. Then let's just click calc, then enter 2 to give us the value of v, and there we go. The value of v is 128. So what about the value of our x is 6? So this will give us 0. So let's check if it is 0. um, our calculator again. So click calc, and click 6, and yes, this will give us 0. And in our last, when the value of x is equal to 0, so therefore this will also give us the value 0. So based from the values of v, what do you think is our absolute maximum? Okay, so very good. So the absolute maximum is 128, because it is the highest value in this equation uh, when we substitute 2 as the value of our x. And what do you think is our absolute minimum? Okay, it's 0. So you might be wondering why there are two different places of our absolute minimum. So you don't need to worry here because there are two different places, but as long as there is only one absolute minimum, that's just okay. So therefore, we have come to a definite conclusion that the largest volume is 128 inches cube, and this is obtained when the length of the side of the square cut out is 2 inches. So this is now the answer in the problem. So next problem is that a rectangular field is to be fenced off along the bank of the river and no fence is required along the river. If the material for the fence cost $4 per running foot for the two ends and $6 per running foot for the side parallel to the river, so this problem is asking us to find for the dimensions of the river or of the field of the largest possible area that can be enclosed with $1,800 worth of fence. So we are going to let x be the number of feet in length of an end of the field. Uh, Also, we are going to let y be the number of feet in the length of the side parallel to the river, and A be the number of square feet in the area of the field. Therefore, it must be A is equal to the product of X and Y, or the number of square feet in area must be equal to the product of the number of square feet in length of the side parallel to the river multiplied by the number of feet in length of the end of the field. So next slide we have here. So going back to the problem, since the materials or the cost of the materials for each and is $4 here, $4 per running foot, and the length of an end is x feet. So the total cost for the fence for its end is $4x. Similarly, in the case of the third side, which is here 6y. So now we have an equation 4x plus 6y is equal to 1,800. So now let's proceed to the real battle. So again, our first step is to find its derivative. So what is the derivative of 300x? Okay, very good. It's 300. How about the derivative of negative 4/3 x squared? So transpose this 2 into this part and subtract 1, the exponent. So 2 times negative 4/3 is negative 8/3. And this will now give us a function a prime of x is equal to 300 minus 8/3 x. And by evaluating it to get the value of x, we obtain x is equal to 112 and a half. So now we already know the value of our critical value, which is 125 and a half, and our endpoints 0 and 125. Let's now find for the values of our absolute minimum and absolute maximum. So to find this, we are going to use um, our original equation, which is 300x minus 4/3 x squared. So if our x is equal to 0, this will give us also 0. So let's try to check this using our calculator. So 300x minus 4/3 uh, x squared. Then just click calc again and input 0, and this will give us 0. So that's great. So next is that we have, if our x is 225, this will give us also 0. But how about if our x is 112 and a half? So this will give us 16,875. So let's check this if this is true by using our calculator. So if our x is 225, and there you go, it's 0. Then if our x is 112, yeah, let's say 112.5, so this will give us 16,875. So what do you think is our absolute maximum in these solvings? Yes, very good. So our absolute maximum is 16,875, and our absolute minimum or is 0. So yes, it is true that the maximum value of A is 16,875, but when it occurs or when x is equal to 112 and a half, the one that we simplified its derivative a while ago, and y is uh, 150. You might be thinking, where did I get this 150? So I obtained this in our original equation a while ago, which is 4x plus 4x plus 6y is equal to 1,800. So when I substitute, or when we substitute x as 112 and a half, so here we get 150. So, therefore, we conclude that the largest possible area that can be enclosed for $1,800 is 16,875, yes, square feet, and this is obtained when the side parallel to the river is 150 feet long and the ends are 112 and a half feet long. So this is now the final answer. Our last problem. So let's read. To supplement the income of Russell, he decided to start a business of driving people home from parties. If Russell crowned them, he can fit 20 people in his dad's old construction van. If his profit from driving X people, P of X is equal to X times 10 minus 0.5X minus 20. So how many people should Russell load into the van to maximize his profit? So let's rewrite our equation. P of X is equal to X times the quantity 10 minus 0.5x minus 20. So by multiplying this, we obtain 10x minus 0.05x squared minus 20. And where did we get that our interval is 0 and 20? Because the minimum number of people he can have is 0. And this is our lower bound, right? Because Russell cannot have negative people in the van, so it's just 0. So, and then the problem says that he can fit 20 people, so probably 20 is the upper bound. So again, what is our first step? Okay, very good. So we are going to find for the critical value using the derivative. So again, what is the derivative of 10x? Very good, it's 10. How about the derivative of 0.5x squared? Very good. It's negative x, and the derivative of a constant is 0. So now we have p prime of x is equal to 10 minus x. And in order for us to find for the value of x, which serves as our critical value, we are going to transpose x into the other side. So the value of x is equal to 10. So now we know already our critical value, which is 10, and our endpoints, which are 0 and 20. Our next step is to find or is to substitute these values into our original equation. So if the value of x is 10, so using the critical value, this will give us 30. So by using our calculator again to check whether it will give us 30, so let's use this 10x minus 0 or zero point 0.5 x squared minus 20, and just uh, click calc and enter 10. So now, yes, this will give us also 30. So what about if the value of x is 0? So this will give us negative 20. So to check this, again, click calc 0, click 0. Yes, this will give us negative 20. And if the value of x is also 20, this will give us also negative 20. So based from these values, what do you think is our absolute maximum? Okay, very good. The absolute maximum is 30, and the absolute minimum is a negative 20. So in the problem, Russell's just finding for the absolute maximum, which is 30, that occurs in 10. But the question is asking how many people should Russell load into that car to maximize his profit. So it's 10 people. So the answer is 10 people, because this will not make his profit big because it's negative, and also this. So it's just like this. If his passenger, let's call it passenger, has 20 people of his, if it is car has 20 people, he will not get profit. He'll just spend 20 US dollars, say US dollars, because of the repairs. It might be overload. It's like that. But if he has no passenger, or there's no people in his dad's car, it, yes, it will not maximize his profit, but it will lessen his profit, because maybe because of the gasoline. And if he has 10 people in his dad's car, he will gain 30 US dollars. So we are just using US dollars here. So it's just like that. um, so to end this, you might be asking that how do you find for the critical value of an interval? So to find these critical points or critical value, you must first take the derivative of the function. So second, set that derivative equal to 0 and solve for x. So each x value you find is known as the critical value. And you might be also asking, how do you tell if a critical point is a maximum or minimum? So this is just very easy. So to determine whether each of these critical points a location or is the location of a maximum or minimum or points of inflection for its value. Test an x value is slightly smaller and is slightly larger than that x value. So if both are smaller than f of x, then it is maximum. So if both are larger than f of x, it is a minimum. So thank you for listening, and I hope you learned a lot in my presentation. So let us continue learning in this new normal. Muchas gracias, mi amigos. Caritas Christi Urgetnos.